Hello. Today we're going to be going over lesson 3.4 on graphing quadratics. Now, hopefully this is a review from last year from secondary math 2. If not, then keep watching this video so that it makes sense to you. But we're going to go ahead and get started. So, if you remember from secondary math 2, there are 3 forms of quadratics. We have vertex form, standard form, and factored form. So this is what vertex form looks like. This is what standard form looks like, y equals ax squared plus bx plus c, which you used a lot in 3.2 when you were factoring into the quadratic formula. And then this is what factored form looks like, which when you took your standard form and factored it, that's what you got on your 3.2 lesson. I'm just going to put in some numbers because sometimes I feel like it helps to see these forms a little more. So like vertex form, if we had some numbers in here, maybe it'd be like 2 parentheses x minus 1 squared plus 1. Okay, that would be an example of vertex form with numbers instead of like these constants a, h, and k down here. So remember that h and k is the vertex of the parabola. So this vertex up here for this example that I just put would be 1, 1. Because h was this 1 and k was a 1, so the vertex is 1, 1. Standard form, if we had some numbers plugged in, it could look like this. Remember, standard form you should be a little more familiar with because we've been using it already in this unit. But we could have like 2x squared plus 4x plus 2. So remember, only the x's are variables in all of these. All the other letters are constants, meaning there will be a number in the problem in those places when you look at them. Okay, so here to find the vertex of the parabola, you have to do negative b divided by 2a, and then you plug that in to get the vertex. All right. Okay, factored form, last one. So if we had some numbers plugged in here, we do f of x is equal to, we'll say like 2x plus 1 and x minus 2. Okay, so P and Q, that should just say P and Q, are x-intercepts, and the vertex is on the axis of symmetry right in the middle of the parabola. So that might have some words that you don't understand what they mean yet, but on the next slide you will. But main things, you should be able to identify something as being vertex form, standard form, or factored form. Then you need to know how to graph each form. So, graphing quadratics. I should say in secondary math 2, going back to here, in secondary math 2, you mostly just graphed your vertex form parabolas, okay? You might have graphed factored form, but we did not have you graph from standard form. So that is a little new here. So just keep that in mind, okay? So graphing quadratics, for each parabola, you're going to find the axis of symmetry, the vertex, x-intercept, y-intercept, domain, range, and whether or not there's a maximum value or a minimum value. So let's talk about each of these things. So your axis of symmetry is going to be it's going to be the line that would split your parabola perfectly in half. So for this one, this axis of symmetry is x equals, that's an equal sign, x equals 2, okay? Because this line is what would cut our parabola perfectly in half. Both sides are symmetrical to each other, aka axis of symmetry. Okay, the vertex is the point on our parabola that is on the axis of symmetry. So for this one, our vertex would be at the point 2, -1. So in this example, my vertex is 2, -1. Hopefully you all remember what a vertex is from secondary math too, but it is that point on the axis of symmetry that splits your parabola in half. Okay, our x-intercepts. Remember, intercept is where we cross the axis, okay? So here's my x-axis, and I hit it right here and right here. So there's actually 2 x-intercepts. So this one would be 1, 0 for our x-intercept. That's a 1. And then this one would be 3, 0. So, and 3, 0. Because remember, x-intercept, that's where our parabola hits the x-axis. Now, I accidentally cut off the y-intercept in this graph, in this picture. So we're not going to find that right now. But just remember, the y-intercept is where your parabola crosses over the y-axis. So there's a way to find that out from an equation for you guys to do, but you can also look at the graph to do that. Just not at this one because I cut it out. Okay, domain. Remember, domain has to do with our x values, and range has to do with our y values. So the domain, this goes on forever and ever and ever. So our domain is -infinity to +infinity. Now, that should make sense because remember, quadratics are polynomials, and we know that with polynomials, the domain is -infinity to +infinity. Okay, and then our range is all possible y values. So looking at here, what are all our possible y values? Well, our y values, the lowest that they can be on this graph is at -1. So our range is going to go from -1, and it includes -1, so we use a bracket. -1, and it goes up forever and ever to infinity, so -1 to infinity is our range. And then we have to determine if this parabola has a maximum point or a minimum point. Well, there's no maximum point, right? Because this goes up to infinity forever. But the minimum is right here. So this has a minimal value, which in this case is the point 2, -1. It's the same as the vertex. Crazy. Okay, so these are just the key features. So here, axis of symmetry. Don't forget it. Okay. I can't write very well with this. And then we have our vertex, which is right here, vertex. And on your notes, you have a little bit of a different graph, but it's all labeled for you on there. The line of symmetry, x-intercepts, vertex, y-intercept, so you can look at that. And then our x-intercept, here's 1. But it crosses at another spot because there are 2 solutions. So that's an x-intercept. Remember, I accidentally cut out the y-intercept, but if we had our y-axis on here, it would cross it, okay? Our domain, you can't see on here, but all possible x values, range, it's the range of our y values, and then this guy is also our minimum point, because there is no point lower than that, so it's a minimum point. Now, something thing, sometimes your graph may go this way, your parabola. In this case, you'd have a max point because that's the highest point on the graph. So that's the difference between max and min. Remember, this flips when there's a negative sign in front of your equation. Okay? All right, moving on, forms of quadratics. So one thing that I think is helpful when you graph these is to first identify what form it's in. You can use the very top of your notes, 3.4, to help you identify what they are. Obviously, you'll need to know it for your test, but let's figure out what these are. So this guy right here, x minus 4 times x plus 9, that is factored form. So if you were trying to graph this in factored form, you would want to look at the top of your 3.4 notes and see that, see how to find the vertex, okay, factored. Okay, this guy right here, this is in vertex form. And the best way to learn how to identify what form it's in, whether it's factored, vertex, or standard, is just to look at a bunch of different quadratics and see what they have in common with the factored form, standard form, or vertex form. Okay, and this last one is standard form. So we have ax squared plus bx plus c. Okay, we're going to move on to graphing. So we are on this second page. Now, this is maybe going to be a lot, but hang in there. You can do it. You can do hard things, okay? So this first one that we are graphing is vertex form. Now, I think vertex form is a little easier. Well, I think it's the easiest to graph because you can automatically see your vertex right away. So, if you remember from the first slide or the first page on your notes, vertex form is written in the form y is equal to a times x minus h squared plus k. Okay, so and h and k, our vertex is equal to h comma k. So looking here, our vertex, our h is 3, not negative 3, it's a positive 3, comma 2. So we're going to go ahead and we're going to plot our vertex on our graph. So we go over to 3 up to 2. Okay. Now we are going to plug in some points, okay? So vertex, we have 3, here we have 2. By the way, there are lots of different ways to graph. And so I'm going to try to teach you this, what I think might be the simplest way, but there's lots of tricks to graphing to help you. So your teacher might teach it a little differently in class. That's okay. I don't want this video to be like an hour long, otherwise I would show you all the ways you can graph, but I don't think that is a great use of time. So, vertex, we have 3, 2. Now, we're going to plug in some other points, okay? Now, we know that a parabola is symmetrical, right? So if I go over 1 on this side and get a point, then if I move to the right on this side, 1, my point will be the same height. For example, let's say we plug in 2. On the other side of 3, we have 4, 5. Notice I put the vertex in the middle. That was on purpose because I want it to be symmetrical, okay? So I have these points, 1, 2, 3, 4, 5. Now, you could easily just plug in 1 to the equation and see what comes out. If you did that, you'd get 1 minus 3, which is negative 2. Negative 2 squared is 4. 4 plus 2 is 6. So here we have 6. So let's go to that point. We're at 1, 6. Okay. And then since we're symmetrical, this guy down here, boom, is also going to be 6. So I'm at 5, 6. Okay. Now let's plug in 2 to our equation. 2 minus 3 is -1. -1 squared is +1. 1 plus 2 is 3. And this guy is going to be symmetrical to here. So this, if we plug it in, will also be 3. So we go to 2, 3. And right here. So last year in secondary math 2, we talked a lot about how you go over 1, up 1, over 2, up 4, and that's how we had you plot the points. You can still do it that way. Remember, it changes if you have a number in front of the parentheses up here. But if you don't remember how to do that, just take some points and plug them in. So I have my parabola. Pretend I hit that line. That point, I mean. Okay, now we are going to look at our x-intercepts now. Does this graph ever touch the x-axis? No, so there are no x-intercepts. We never hit the x-axis, okay? Our y-intercept, it's kind of hard to tell where we're gonna hit it. So if you need to find a y-intercept, you're gonna plug in 0 for x into the equation. This works for any equation ever in math. Doesn't matter how simple or complicated it is, but if you ever want a y-intercept, you plug in 0 for x. Okay, so when you do that, to this problem, we'd get 0 minus 3 squared plus 2. So that's -3 squared plus 2. So that's going to be 9 plus, that's a 9, plus 2. And that's going to equal 11. So our y-intercept is at 0, because we plugged in 0 for x, that's why that's 0, comma 11, because 11 is what we got out. Our domain, how far left can our x values be? Well, it goes on forever, so our domain is -infinity, and how far right can our x values go? To +infinity. It's our domain, and our range, what's the lowest we can go on our range, on our y values? 2. And it goes up to infinity. So, does this have a maximum point or a minimum point? Well, it looks like a minimum, right? Because there's nothing that's lower than this point. So our minimum point is 3, 2, which matches our vertex. Hint, hint. Okay, and our axis of symmetry comes down the middle here. So that is the line x equals 3. Okay, so that's vertex form. So to review, we found the vertex, plotted it, plugged in some points, connected everything, and filled in this stuff over here. So when it's in standard form, it gets a little harder. So the first thing that you are going to do is you're going to find the vertex. Now, if you look at the very top of your 3.4 notes, in that box that says quadratic functions at the top, you are going to want to look at the standard form box, okay? So standard form says that -b over 2a is the vertex of the parabola. So our vertex is equal to -b over 2a. You might be wondering, what is b? What is a? Well, remember, our standard form is always written in the form ax squared plus bx plus c, right? That's standard, S for standard form. So, looking down here, what's a? What's in front of our x squared? Well, a is going to be our -1. So we're going to have 2 times -1 on the bottom. And then what is b? Well, what's in front of my x? It's 4. So we have -4 over 2 times -1 when we substitute in b and a over here. So I get -4. 2 times -1 is -2. -4 divided by -2 is 2. So the first, my x value of my vertex is 2. Now to find our y value in our point, we're going to take this 2 and we're going to plug it into this equation, okay? So when you do that, you have to plug it in for x. We have negative and then in parentheses 2 squared plus 4 times 2 minus 3. So whatever this equals is going to complete our vertex point, okay? So this is going to be -2 squared is 4, so -4 plus 4 times 2, which is 8, minus 3. So we go left to right, 4 minus 3. So we get 1. So our vertex is 2, 1. Okay, so let's plot that. 2, 1. Now, remember, when you see that, put that in your middle box. Boom, right here. Okay, vertex goes in the middle because our parabola is symmetrical. So when we go fill this in with the rest of the numbers, 0, 1, 2, 3, 4, it's going to give us symmetrical points. Okay, so if we were to plug in 0 for x, we'd get 0 plus 0 minus 3. So this is -3. Remember, this point, do a little rainbow, boom, is going to be symmetrical to this because they're the same distance from our vertex, okay? So we have a point at 0, -3, and a point at 4, -3. Okay, now let's plug in 1. 1 squared is 1, -1 plus 4 times 1 is 4. So -1 plus 4 is 3, 3 minus 3 is 0, so this is 0. And remember, these two are symmetrical, so we're going to put in 0 there. So we get 1, 0 and 3, 0. And then we connect our parabola. And we have our points. So you might notice that this guy, this parabola, is flipped upside down. It's pointing down. It looks more like a hill instead of like a U shape. And that is because of this negative sign right here. So if you have a negative in front of your quadratic, it's going to reflect your parabola over the x-axis, aka it's going to flip it, okay, so that it's upside down. So let's find our axis of symmetry first. Remember, it's going to be the line that's going to cut our parabola perfectly in half. Give you a hint, it's always like where the vertex is. So our axis of symmetry is x equals 2. There's the equation of the line right there. Okay. Now our x-intercepts, that's where our graph hits the x-axis. So here we have a point at 1, 0 and 3, 0. Okay. Our y-intercept is where our graph hits our y-axis, and we can actually see that point right here. So that is 0, -3. Now remember, if we couldn't see that point, we would just plug in 0 for x, and we would get out -3. Our domain, how far left and right can we go with our x values? Well, we can go -infinity to +infinity. Our range, what's the lowest our y values can be? Well, it goes on forever that way, so it's going to be negative infinity. 2, what's the highest point we can be at for our y values? 1. With the bracket on this side. Is this a max point or minimum point? Well, it's the maximum because this is the highest point on the graph, so it's a max. So that's how you do standard form. Remember, use that little quadratic functions table at the very top of your 3.4 notes. So you remember that to find the vertex, you do negative b over 2a and then plug it in. Okay? All right. Last one is going to be in factored form. Now, factored form is kind of fun. So you might remember from solving factored form that factored form is pretty easy to identify x-intercepts, right? Because we'd have x plus 1 equals 0. If we split this up and we have x minus 3 equals 0 to find our x-intercepts. So if we solve for x, we get x is equal to, we'd subtract 1 from both sides, x is equal to negative 1. Over here, you'd add 3 to both sides, so that's equal to 3. So we're going to have our x-intercepts at negative 1, 0, and 3, 0. Okay, now, this is where it gets a little different than all the other things we've been graphing. We know that there's going to be an axis of symmetry, right? This point is equidistant from the axis of symmetry as this point is. So we're going to count to the middle of these 2 points. So if I go in 1, 2 on this side and 1, 2 on this side, I find that my axis of symmetry is right there, right? Because look, this point is equidistant from the axis of symmetry because it's 1, 2 away from the axis of symmetry. And this point is also 1, 2 spots away from the axis of symmetry, okay? So that's why I put the axis of symmetry right in the middle. So now that we know where the axis of symmetry is at x equals 1, to find our vertex, we're going to plug that 1 in to get our y value. So when we plug 1 in here, we get 1 plus 1 negative and 1 minus 3. So we get negative. 1 plus 1 is 2. And then times that negative is negative 2. And then 1 minus 3 is also negative 2. Well, negative 2 times negative 2 is a positive 4. So our vertex is at the point 1, 4. So we go 1 to 4. Okay, so vertex is at 1, 4. Our x-intercepts, we already found them when we solved for x up here. So we have an x-intercept at negative 1, 0. And an x-intercept at 3, 0. Okay, now we need to find our y-intercept. So remember, to find your y-intercept, you're just going to plug in 0 for x, okay? So our y-intercept is going to be y is equal to negative, plug in 0 for x, for any time there's an x, so we have 0 plus 1 times 0 minus 3. Okay, so y, that's a y. Y is equal to 0 plus 1, which is just 1, a negative. We'll leave it in the parentheses. And 0 minus 3 is negative 3. Well, negative 1 times negative 3 is a positive 3. So our y-intercept is at 0, comma 3. Okay, So you can plot that point. Oh, look, this one's 1 away from the axis of symmetry, so that means this guy over here is also going to be 1 away. So if you were to fill in your table, which you don't really have to, because your table is more to help you graph, and we already graphed everything, but this is what it would be. So remember, this y value is going to match this y value. This one's going to match this one. So our domain, how far left can we go? We can go all the way to negative infinity. With our x values, we can go all the way to the right, positive infinity. Our range, that's a funny looking parabola. Our range is going to be, the lowest we can go is a negative infinity, right? Because it goes on forever, low that way. And the highest we can go is to 4. So is that a max or a min? That is a max. So to review, make sure that you use your notes to help you graph. Make sure you know how to find an axis of symmetry, a vertex. Those things are going to help you with your graphing, okay? Don't forget, you can go to Math Lab Monday, Tuesday, Thursday, or Friday from 2:30 to 3:30 if you need some more help. Or you can ask your teacher. That is it. Have a great day.